So question 4a tells us to solve the equation x squared minus 6x minus 23 equals 0, and we have to give our answer in the form a plus or minus b root 2, where a and b are integers. Now the fact that they tell you this, that your answer has to be a plus or minus b times root 2, is a very strong implication that you can't factorize this. You have to use the quadratic formula. Now you find the quadratic formula on page 20 of your Formula and Tables book, but it looks like this. We have an x, and that's equal to minus b plus or minus root of b squared minus 4ac, and all of that gets divided by 2a. Now what do all those letters mean? Well, a is the coefficient of x squared, so in this case that is 1. B is the coefficient of x, so in this case that's minus 6. And c is the constant, which in this case is minus 23. So all we have to do is substitute those in. So instead of writing minus b, we have minus 6. Keep the plus or minus where it is for the moment. It'll come in again at the end. So we have minus 6 squared, and we subtract 4 times 1 times minus 23. All that gets divided by 2 times 1. So we just do a bit of simplification where we can. The minus times minus 6 is going to be a plus 6. Plus or minus 6 squared is going to be 36. We have a minus 4 times a 1 times a minus 23, which is going to be a plus 92. All that gets divided by 2. So we just kind of simplify this a bit further. Keep a few things as they are. 36 plus 92 is 128. And we're dividing by 2 again. Now the only thing we can really do with this is try and take something out of this square root, because we can't evaluate it as it is. Now the fact they tell you to give your answer in the form a plus or minus b root 2 means that you should try and take a root 2 out of this. And the way you do that is you say that 128 is 64 times 2. So root 128 is root 64 times root 2. And that still gets divided by 2. So as we progress further, we have a 6 plus or minus root 64, we know is 8. We still have a root 2 there, divide all that by 2. And just the last step, we can get rid of this fraction here. So 6 divided by 2 is going to be a 3, plus or minus 8 divided by 2 is going to be 4, and we're left over with that root 2. Now, part B asks us to solve these simultaneous equations. We have 2r minus s equals 10. I'm going to call that equation 1 for the moment. And we have rs minus s squared equal to 12, and I'm going to call that equation 2. Now my favourite way of doing these is by substitution. So what that means is we try and rearrange one of the equations in terms of one variable, and then just replace the variable in the other equation. So the easiest way to do that is to take equation 1, the linear one, and try and replace that. So I'm going to try to get this in terms of s. So that's going to be s is equal to 2r minus 10. And now I can replace s in the second equation with 2r minus 10. That was the goal here. So now I go back to equation 2. Instead of writing rs minus s squared is equal to 12, I'm going to have or times 2r minus 10 minus 2r minus 10 squared is equal to 12. So pretty much the same as the equation was before, except instead of s, I now have 2r minus 10, which I figured out a moment ago. So just simplify this as much as possible. Distribute these brackets. So or times 2or is going to be 2or squared. Or times minus 10 is minus 10 or. And we're going to subtract the content of this bracket. So when you square this bracket, you're going to get 4or squared minus 20 or minus another 20 or, and plus 100 is equal to 12. So we just carry on simplifying where possible, distributing these brackets. The 2r squared minus 10r are going to stay the same for the moment. I'm going to end up with a minus 4r squared. This minus 20r and minus 20r are going to be minus 40r altogether. When I bring in this extra minus, that's going to become a plus 40 or. And lastly, this minus times this plus 100 is going to be minus 100. And I'm also going to bring this 12 over. I'm going to subtract 12 from both sides, whichever way you prefer to think about it. And I'll be left with equals 0 on the other side of the equation. So now we just tidy it up as much as possible. We've got 2r squared minus 4r squared, so that's going to be minus 2r squared. Minus 10r plus 40r is going to be plus 30r. And we have minus 100 and minus 12, which will be minus 112, all totaling 0. We can simplify this a little bit before we go any further. I'm just going to divide everything by 2, so we have minus r squared plus 15 or minus 56 equals 0. And I'm also going to change the signs of all these. If you want to think of it as bringing everything over to the other side or multiplying everything by minus 1, either way it will work. So I've got r squared minus 15 or and a plus 56, which all total 0. Now what I have here is a quadratic equation. The way I like to solve these is by grouping. There's literally tens of ways of doing this, so this may not be the way you're used to it. I'm going to take the coefficient of r squared, that is 1 in this case, and the constant, and multiply those together. So I've got 1 times 56, which of course is 56. I'm just going to try out a couple of different factor pairs of 56. So let's say I've got 1 and 56, 2 and 28. I will have 4 and 14, and I'll also have, let's say, 7 and 8. Now I'll try and add these together. So 1 and 56 is going to be 57, 2 and 28 will be 30, 4 and 14 is 18, and 7 and 8 is 15. Now you may notice something about this, that when we add the 7 and 8 together we get 15, but 15 is also the coefficient of r, well, minus 15. We can fix this easily by just saying minus 7 and minus 8 are two numbers. They'll both multiply together to get the plus 56 that we're looking for, but they'll also add to get a minus 15. So this minus 15 is exactly this minus 15 here. So what we do is, instead of writing minus 15 or, we replace that with the other two numbers, the minus 7 and the minus 8. So we have r squared minus 7 or minus 8 or plus 56 equals 0. So we do what we can now to factorize what's common in pairs. So between r squared and minus 7 or, we have an or common, and what's left is or minus 7. Between minus 8 or and plus 56, we're going to say the 8 is common, and even more than that, I'm going to say a minus 8 is common. That'll leave me with or minus 7, all totaling 0. Now notice between these two blocks here, or minus 7 is common, so if I can factor that out as well, I will end up with or minus 7 times whatever's left, the or minus 8. So now we have two numbers multiplied together. We have or minus 7 multiplied by or minus 8, and their product is 0. The only way that happens, of course, is if one of those numbers is 0. So we have one case where or minus 7 equals 0, in which case, of course, or must be 7, because only 7 minus 7 will get you 0. And case 2 is where or minus 8 equals 0, in which case, of course, or must be 8. So that's half the question done. We're asked to solve these simultaneous equations. We have two different values for or, and there should be two values for this type of question, so we're doing well enough there. But we don't know what s is. Well, we have a formula for s. We know that from equation 1, s is equal to 2r minus 10. So if we go with case 1 where r is 7, we say that s is equal to 2 times 7 minus 10, which is going to be 14 minus 10, which will be 4. Or we have another case where s is going to be 2 times 8 minus 10, which will be 16 minus 10, which is 6. So our solutions are, if r is 7, then s is going to be 4. Alternatively, if r is 8, then s is going to be 6.